and welcome to Lambda U. My name is LICOrbio and I am a LICOR Solutions and Support Scientist. Today, we're going to be talking about the BCA assay. So let me start by telling you a little story. When I was a young grad student, I did a lot of Western blots. That also meant a lot of protein assays, day in, day out. After a while, started seeming like a little waste of time to do a standard curve on every single assay. So after a few months, I gathered the courage and I went to my postdoc and I asked her if maybe I could skip that part of the assay and just average all the data I had. Well, to my surprise, instead of just giving me an answer, she told me to run a little test and told me that the next time I had to do a protein assay, I should run, in addition to the standard curve I always did, 2 more standard curves. One where I shifted the pH of the standards and one where I used something other than BCA. To my surprise, data was completely different. So I learned my lesson, and since then, I always use fresh standard curve on every single protein assay, and I always double check the data sheet to make sure I didn't miss anything that's relevant for the test. Okay, so why should you care about running a protein assay before every single Western blot? Because knowing how much protein you're loading on each well is one of the first steps to ensure you can get accurate quantitative Western blot data. Now, keep in mind that in addition to that, this is also going to save you time, resources, and even samples on the long run. Also, don't forget that internal loading control normalization does not substitute for knowing how much protein you're loading. Matter of fact, you actually need both of those things, knowing how much protein you're loading and normalizing by a validated internal loading control to make sure that the differences that you see in protein expression are not due to pipetting errors or even transfer issues. Let me tell you a story that might help you understand why it's so important to always run a protein assay before every Western blot. Let's say I have samples that are frozen and I'm ready to run my Western blot. And I don't do a protein assay, so I'm not sure how much protein I'm actually loading on each lane. I try to load a similar amount, but I can't be sure. By the time I look at my data, I have the impression that my target is actually having differential expression on each one of those samples. However, had I done a protein assay and loaded the same amount of protein on each lane, I would know for a fact that that target expression is the same in all of my samples. Reason for that is because different proteins have different stability levels in different conditions. And if I don't know that I'm loading the same amount of protein in each well, I can never account for that. Today, we're going to walk you through the BCA protocol step by step. And we're going to talk about what are the scientific principles behind the BCA assay. We're also going to talk about how we can properly use the BCA assay to estimate protein concentration, as well as what are the best practices for the BCA assay. Just keep in mind that we're not going to go in depth about how to choose the protein assay that works best for your samples. That was already addressed on the other Lambda U course, estimating protein concentration.